For this next example, we're going to take a look at a very similar workflow of how we can use panelizing a surface to create a 3D frame, like a space frame. So we'll be using a similar approach of lofting together a surface, kind of basically dividing that surface, panelizing it into a series of different panels based on some U and V divisions, and then creating some framing lines. This is going to be a little bit more involved because rather than just kind of getting the edges around the panels in kind of like one dimension, we're going to basically get those panel edges. We're going to figure out what the center point of those different panels are and project that down to get the vertices of a bottom layer. Then connect together the top and bottom layer with some diagonals. Finally, connecting the bottom panel edges out of all those different like vertices that we've computed. And then we're going to basically get a space frame out of all of that. Okay, finally we'll visualize that, but let's go ahead and show you what I mean. That might be easier to see than it is to sort of explain. So the idea is, again, we are going to start with some very simple sort of parameters, things about like the roof itself, the roof origin, maybe some parameters to define, attributes of the roof. In this case, we're going to create a space frame under a very wavy roof. So we're going to use some sine wave functions and he did a curve amplitude and some number of waves. We have the overall length and width of the roof, as well as the depth of the frame and some panelization parameters. And what we're doing is creating a frame that looks like this. So it has two layers to it. It has an upper layer and has a lower layer to it. And if you look at it in plan view, you can sort of see what happens more clearly. We have the upper layer, which are the panel edges. We compute a center point for each of those different panels, and then we connect those together. We create some diagonals that come down to that center point, and then we connect those lower points to create the lower edge of the space frame. Looking something like this. And again, it's a really kind of nice example of how you can use Dynamo to very quickly kind of generate some surfaces. So if we do things like we want to change the fineness of the panelization, we want to change the depth, or we want to do something to change, the quality of the surface. Here I've just lofted together three different sine waves that are all parallel to each other, but you could change the waviness of each of those, or you could really make almost any arbitrary surface, and the same technique will work. Okay, so let's take a look at the steps to go through and implement this workflow.